And I am not the project technical lead for OpenStack Swift. I have been involved with the Swift project since 2009, and I'm now Director of Engineering at SwiftStack. I was the PTL. I'm not now. I will come back to that later. But this is my last 40 minutes on stage giving a project update, so you get to listen to what I want to talk about. And today, what I want to talk about is the history of Swift. I want to tell the story from the very, very, very beginning. So let's go back in time, and we're going to go back to the very beginning of time, circa 2006. And in 2006, the world looked very different than it does now. Around 2006, 2007, that sort of time frame, S3 launched as one of the first AWS services. Rackspace customers were asking for a very similar thing. They needed some scalable storage that needed to be partnered with this new type of application that they were building. They were building applications that were going to be much more horizontally scalable, and they needed some storage to go along with that. So Rackspace created this new product called Cloud Files. And Cloud Files has an engine behind it called NAST, N-A-S-T. And it was a distributed storage system with a centralized bookkeeping layer, which basically meant that you had a whole bunch of hard drives spread throughout all of the servers, and every time you wanted to read or write one, there was a big database that you looked up, where am I going to put it on that hard drive. When you come into a read request, look up where it was, go read it from that hard drive. So it works just fine, except it's kind of hard to scale. It's not something that's really good from an ops or sysadmin's perspective. And so the product at Rackspace suffered from rapid growth, as all problems from ops start with. And the executives came to the team and said, you need to make it better. But customers can't know, because we're not going to announce we're going to rewrote everything. So we had to make the migration seamless, and in order to do that means that you have to keep the same API, so application clients don't break, and that kicked off Swift. Coding for Swift started in 2009 at Rackspace internally as this internal project to replace the existing storage system that was there, and that brings us to 2010. In 2010, Swift was first launched into production on May 17th. And OpenStack launched later in June. And in fact, I had two babies born within weeks of each other in 2010. My youngest was born on April 26th, and Swift was born on May 17th. So they're both having birthdays right around now. I'm going to leave out a ton of stuff that we have done as a community. And I'm going to go very quickly through all of this. But one thing to start is, one of the roles as a PTL that I have really enjoyed is hand curating the changelog on every single release, which basically means that every 6 to 8 weeks, I am able to look back over the Git commit history, and it's basically just write up a hits list of, look at the amazing stuff that this team and this community has produced. And it's never been a burdensome task for me. It's always been this celebration of things that are great that the community is doing. And so looking back over the changelog, that's where we're going to get to this very fast overview. So by the time 2012 came around, we had some S3 compatibility. We had a bunch of ops tools there. We had re-implemented posts as an internal copy feature. It was updating object metadata, and that was hard to do in a container listing, so we figured out the posts weren't very common, so we just implemented it as an expensive copy operation on the back end. And that worked pretty well, but come back to that. By the time 2013 came around, we had extracted Swift 3 S3 compatibility into its own separate project. It was absolutely the right call at the time. Stay tuned. We had also implemented this thing called unique as possible placement. And this was a great feature that allowed for a lot more varied clusters. It removed a major barrier to entry. It allowed for a lot smaller clusters to be deployed. Instead of having to say you have to start with the infrastructure that Rackspace started with, you can start something that's much smaller, all contained in one rack, and we continue to build more ops tools to help support that. By the time we got around to later that year in 2013, we had taken that and added on multi-region clusters. And it turns out that multi-region clusters are huge. It seems like almost every single deployment that I know of these days uses them. We also started adding functionality to handle full drives. And this is really kind of fun to look at because while it's a terrible problem and something that needs some careful consideration, it means that there were actually people starting to suffer from full clusters. Those removing barriers to entry, people start using it more, they start adding data, and then it's like, oh no, what do I do? And then also, there was a little experiment that I played with in 2013 of running Swift under PyPy. And I just thought this was kind of fun. It was our first big attempt at some large-scale optimization attempts. The next year, by the time we'd gotten around to Icehouse release, we'd added several key things that became foundational for a lot of future features. First is the /info support, which is a client discoverability of what does this cluster support. And it is used almost everywhere for almost every single client operation that you have. What's the maximum object size? What features are supported? How should I talk as a client to this particular cluster? We also added in a different way to do replication. We added an abstraction layer for how we're actually talking to hard drives, and we added in the ability to store some kind of internal system metadata. And all of these come back were reused in key features later on. On a community front, at this point in the evolution of the community, Swift contributors had switched away from Launchpad blueprints by way of tracking new work. And we'd started in this new experiment at the time of, we're going to create specs, and we're going to have a common repository for how we're going to do that. And that's where we were there. Later that year, by the time the Juno release came around, we had created storage policies. Storage policies, in my opinion, are the biggest single feature that has ever happened in Swift. And that is what caused us to go from a 1.x release to a 2.0 release. This change was basically like changing the transmission in a race car in the middle of the race while it's on the track. It was absolutely massive and allows you to have a much more configurability on how you're able to store your data. The important thing about storage policies is that this was the first major feature that we developed as a community that was truly a global effort. It was one of the most amazing things that I saw, and this was the first time it happened, it's happened multiple times since, where somebody goes to sleep at night, and as they're getting offline, somebody else is coming online, picking up that work, and they're working throughout their day and passing it off when they get off work that day into the next. And you just saw this work of effort, especially in the last few weeks as we were finishing up the reviews and the merge for this big feature. Just you saw it travel around the world a few times. It was absolutely incredible to observe and to watch. By the next year, we had added, on top of storage policies, the ability to durably store things using erasure codes. And we changed the unique as possible to this unique as distributable sort of concept, which is a terrible mouthful, but it is still what we're using now. And the great thing is that it makes it a lot smarter so that you can deploy across a lot more heterogeneous hardware. So you have some servers that are huge with 80 hard drives, and some servers have 12 hard drives. And how do you appropriately balance that when you're actively balancing clusters in here? And it's things like this that tell me about the kind of usage that people were doing there. They're rapidly growing, they're adding new kinds of hardware and all that kind of stuff. By the next year in 2016, we had added on a new versioning mode. We had added an internal optimization to have servers per drive, which dramatically improved the way work was distributed out in big servers. And this is also in 2016, one of the big topics of conversation here was implementing an object server in Golang. Also, on the community front, we had moved away from specs in 2016, and we created this new idea called Ideas. It's this idea wiki, where the whole idea is if you have an idea, you need to write it down and link to it. That's it. And it's still the plan we're using now for tracking community work overall, and it's absolutely fantastic, and it's really working well. By 2017, we had added in something called composite rings. Composite rings allows you to have explicit data placement. Rather than just saying, here's my cluster, figure it out, you can explicitly say, put 2 copies here and put 1 copy there. And in fact, we used composite rings to add on the functionality for being able to do multi-region erasure codes. So you can say, I'm going to erasure code this for more efficiency, but I'm going to replicate those fragments into a different region, and that's implemented using the composite ring functionality. By the next year, we had gotten to 2018, and we had continued to enhancing existing features. We had added some more functionality onto our at-rest encryption features, added some inline data segments, and to allow some storing new kinds of data. And we had added support for symlinks. And then by the end of 2018 in the Rocky release, by this time we had implemented container sharding. And container sharding is the biggest single feature that Swift has ever released. It's not big in the impact, but I mean, hugely impactful. It was 10% of the code when it landed. And this thing was developed for 4 years. And it was just an absolutely amazing effort by the whole team, led by Matt, that was absolutely fantastic. And also in the Rocky release, we saw Swift 3 again. We integrated the S3 external project and reintegrated back into upstream Swift so that anybody who deploys Swift can immediately have both a Swift API and an S3 API, and we can make sure we account for all of that, those different APIs when we are doing new features. So that gets us, you may have noticed that there aren't quite as many huge big features that are being delivered quite as often. And there's no avoiding that fact, but we can in fact talk about some of the why. And so you may say, well, is this just a natural progression of a project that is 10 years old? And I don't think so. I think that there are many things that we would like to do if we had the contributors. I mean, I can think if we had double the contributors that we have now, I can easily think of 3 years of work to keep us all busy. This is a graph of the active contributors. The top line's on a monthly basis, the bottom line's on a weekly basis, just kind of averaged over time. And you can see the contributor count to Swift did peak over in 2016. And trust me, it does say 2016. I know it's tiny words there. But this is caused by lots of things. We had HPE left, Intel left, Rackspace left, IBM left the community. And these had different reasons behind them. Some of them decided to sell off whole business units. Some of them were acquiring competitive projects. And some of them were just refocusing away from cloud. And that's all totally valid, but you can see that they do have an impact on our community and who was contributing. And even furthermore, inside of OpenStack itself, there were certain demotivating decisions that severely hurt our community in particular. And it was, some of these things hurt, and some of them more than others, and some of them were more personal than others. But we're still here, we're still working on features. Swift is still being widely used, and in fact, it's being used even more than ever. So talking about usage, Swift is being used all over the place. In games, in media, in research, scientific research, in telecom infrastructure, pretty much any sort of data that still needs to scale, Swift is there. And in fact, even recently, this was so exciting to me that Swift is part of the reference architecture for NVIDIA's new self-driving car autonomous infrastructure stuff. It's incredible where you see this kind of storage system being a key requirement, not just a good idea. So let's talk about what's in the current release, the OpenStack Stein release, which is Swift 2.21. We've got a few major things. One is we've improved some erasure code support. One of the key things we've improved on erasure code support is being able to automatically reconstruct fragments on a drive failure. This brings it into parity with replicated storage. We've also improved and made multi-region EC much more efficient as far as the data being transferred across between the clusters. We've also made significant improvements to data encryption, allowing to migrate from one key master to a different one, so you can have like 2 different key storage things and move between them, which can be handy. And we've made a lot of improvements to S3. And some of these are regarding particular features, but there's been a lot of features that have to do with behavior mimicking. It's not good enough always just to have an API endpoint that is the same, but you want it to behave the same way so the clients continue to work. So one of the examples on this is when you're doing a bulk delete of a lot of different things. Swift has had this for a while and S3 has this, but our S3 compatibility now has the ability to emit heartbeats afterwards, so it keeps the connection alive. And there's things like that that we've continued to add to the S3 compatibility. And there's a lot of work that is continuing. It's currently being worked on. We're continuing to work on it, and these are things that you can probably expect to see in the next several releases, or at least in future releases of Swift. The first one is a big one, talking about Python 3 compatibility. And this is something that has been affecting all of OpenStack and affects the entire tech industry, really, anywhere that Python is. And the good news is our progress is good on this. We've got close to 65% of our unit tests and about 40% of our functional tests running and passing in the gate for Python 3 compatibility. And our goal is currently the end of this train release that has just started.
But there is a lot of work yet, and there are a lot of challenges with this. And some of the major challenges really have to do with how does one migrate an existing cluster from running under Python 2 to Python 3. And these are the kind of things that are really hard, because we have data that was literally written on a hard drive 10 years ago that we still have to maintain, still have to be able to successfully deserialize. And as part of this experimentation, we have discovered at least 5 bugs in Python, not like Swift written in Python, in CPython itself, 3 of which are still open, 2 of which we have patched. And on those, 4 of them have active conversations and patches from Swift contributors on those 5 bugs. We've also found several bugs similarly in Eventlet, and most of these things have to do with HTTP protocol and Unicode sort of issues. And then there's some serialization issues, again, like being able to handle the migrations. It turns out that there are some segments of some versions of Python 2.7 that are unable to unpickle a data that was pickled in Python 3, which are like, well, why are you going that way? Well, because maybe you stored it into Py3 on a server there because you're doing a rolling upgrade, and the hard drive died, and the data got copied back to something that hasn't been upgraded yet. And at that point, you can't have that data loss and data corruption by being unable to do that. So these are a lot of the challenges that we've been doing and some of the reasons why our Python 3 porting has been rather painful. Another thing that's ongoing is lots of small files work. This is something that is seeing wider use inside of OVH. Some good news on the progress on this. It is now tracked and managed as a feature branch upstream, which gives us a good path to and gives us plans for actually merging that into master. So the basic lots of small files design is pretty interesting. Remember I talked about the disk file API that we invented years and years and years ago. The lots of small files design creates a new kind of disk file and says, here is, if a file is small, here's how we're going to handle it in this separate way. Rather than just writing it down into its own unique file, we'll manage it as part of some slab that's a larger file on disk. And then we've got a new thing called an indexer that is a new daemon that is able to to keep track of what's the health of those slabs and what's inside of those slabs. And that indexer is written in Golang, and it uses gRPC for the interprocess communication between the object server and that indexer. However, there have been quite a few challenges on this, one of which is just hard to get reviews on seeing this code and putting the necessary parts together. Some of the other issues have had to do with eventlets and gRPC and Python and making sure that those things actually work well together. Another thing that's going on is some S3 API compatibility. We're continuing to improve this. And the good news is, as far as Swift's S3 compatibility goes, there are very, very few feature gaps remaining. In fact, especially when you compare it to other competing products out there, the good news is S3 API is fully integrated, and one of the key things that we're working on right now has to do with kind of they're big changes. Like, for example, one of the things we're working on is adding on a good full fidelity of S3 versioning. But to do this, we want to re-implement the way that versioning works in Swift itself. We've got symlinks now, and so what would be great is you put the canonical copy here, but your reference copy is simply a symlink to it. So it's much cheaper to manage, as you can only update a symlink when you do that. However, rechanging the way that versioned objects work in Swift so that you can add an S3 compatibility layer on top of it does make for a rather substantial change. The other thing that we're working on when it comes to S3 API compatibility is how to deal with asynchronous events, things that you don't want to happen right now. And Swift does some of this, and it does some of this pretty well, but in general, Swift is designed that a request it goes into that, it's just a data path sort of thing, and then it gets a response right then. It's not something where you send a request and then later on you may queue it and query it and figure out what happened. But when you talk about S3 compatibility and a lot of other things that people want to do, for example, what happens if you say, I have a container inside of Swift, but say after 30 days and a particular metadata tag is triggered, then I would like to move it to a different cluster. How do you describe an API for the user to do that in such a way that that operation can be executed 30 days later? And that's one of the active topics of conversation for this week, at the end of this week at the PTG. So speaking of the community, there are lots. This is 400 people. This is the author's file in Swift. It's 400 people who have contributed code into the repository itself. And this does not include the more than 400 who have also offered reviews. On a total, we've got 805 contributors to Swift. These companies here are the main contributors and leaders in the community. SwiftStack, OVH, SUSE, NTT, and Red Hat have all been doing great work in the community and continuing to push it forward. Other community news is we have a new core reviewer from OVH. Romain is here, and I'm thrilled that Romain is a core reviewer on Swift now, and also would like to thank OVH for their continued commitment to the community, both from sharing the ops expertise that they have, but also working on new features. And also, we've got a new project to lead. So why did I step down? Why am I not the PTL anymore? A question I'm sure many of you are in the room to get the answer on. I've been asked to take on some more responsibilities at my employer to do some more management and leadership sort of things. And frankly, I just realized I cannot do both that and PTLing and do either one of them at all effectively. And I was looking for new challenges for me to learn new things. So Tim Burke is the new project technical lead. And he is absolutely fantastic and will do an amazing job on that. And I would also like to thank SwiftStack for the continued commitment to the community and offering a huge amount of development and related to actual production usage and leadership in the community. So my vision for Swift is something I say quite a bit. And my vision for Swift is that it will be used everywhere, every day by everyone, whether they realize it or not. And we think about the kind of use cases where Swift is being used. It's really, I get blown away all the time. Even in recent history, I've been involved in this project, like I said, for 10 years. And I have been amazed and amazingly fortunate of all of the places that Swift has taken me. And you walk through a data center someplace and you realize, they're archiving ancient movies here, or you walk through another building and they're doing massive esports thing, or you're touring giant churches in Barcelona from the summit that was there. And it's amazing the places that Swift is being used, the places that Swift has taken me around the world. And I'm still always blown away by the use cases that I know about and the things that I briefly hear about. Seeing Swift used today as the back-end infrastructure for your cell phones, as seeing Swift used actively by millions of people playing video games, seeing Swift used for doing post-production house stuff for movies. And these are all things that are not only have happened over the last 10 years, but are happening today. And it's been amazing. So I think we're getting towards this goal. We're never going to be there, and it's always something to strive forward, but it is amazing to see what we have done. So why does it all matter? Like, who cares? It's a giant hard drive in the sky. And it's not. It's a whole lot more than that. What was the original why for this? Way back in 2006, 2007, and when Swift started in 2009. The original reason was that people were starting to conceptualize and write applications in a little bit different way. I need to have some scalable applications, sometimes elastically scaling, and be able to access large amounts of data. My data requirements are getting a lot bigger, and the data that I need to access in order to make decisions in my applications is getting a lot larger. And in order to do that, I can no longer rely on just storing my data in a traditional database or on a local file system on a local hard drive. I need to have a new way where I can, on demand, via an API, simply put some bytes, and later I will get them, and I don't have to worry about those hard problems of data storage. I can simply say, I need a picture, give me a picture back, that's it. And so, does that still apply? Does that why still matter? Yes, absolutely. And the vision matters more than ever because cloud applications are more common now than they were 10 years ago. We even look at new technologies that are coming on with containerization and serverless functions and stuff like that. We've got new applications that are needing ever more data storage just to make smart decisions. You start looking at what people are doing with machine learning, AI, things like that. Like their data usage starts with a few dozen petabytes for a small lab. And then they go from there and they add insane amounts of storage all the time. And their models get better and better the more petabytes they have associated with it. And so all of this put together, object storage is no longer just an interesting and a good idea. It is an absolute imperative for everyone. This project, even more so as Swift, as part of the OpenStack Foundation or Open Infrastructure Foundation, it matters more than ever, because what we see is that we need to have an open source software that is designed in the open with open community that is still cutting edge tech and is not something that's a few generations behind. If the only thing that was available for these applications was a proprietary object storage system that you couldn't actually see, then we will lose an entire generation of what is possible. And how are we going to figure out how to do the next thing? Everything that we have built and everything that we are going to build is built on top of that which came before us. So we are that which came before for the next generation. And we can't abdicate our responsibility there by simply not creating, not embracing, not leading the technology by doing that in the open so that we can all learn and share from it. So all of that put together, thank you for 10 years. I'm not leaving. I'm still going to be involved in the Swift ecosystem. And this project has been literally half of my career. There's been good times and there's been bad times, but it's always been an honor. And the core team that I've been able to work with in the Swift project is an absolute phenomenal group of people and the best devs that I have ever had the privilege of working with. And I really cannot say enough good things about any of them. I'm immensely proud of what we've accomplished together. And I think the future is absolutely bright. So thank you. We do have plenty of time for questions. I thought I would go longer than that. But do you have any questions about any of that? What's happened in Swift? What's going on? What might happen? Community? Wow. Yes, James.
I've become accustomed to typing the word Swift into any IRC channel that I've joined.
Mm-hmm.
And you immediately pop up and start answering whatever questions I've had, often before I even ask them. And it's been great, and I want to thank you for that.
Oh, thank you.
And to turn this into a question, will you or other folks still be around to do that?
Okay, so the actual question for the video is, will I still be around to answer questions in IRC and to do that? And yes, at least for the short term, absolutely. I've still got my IRC bouncer logged in. I'm still going to pop into IRC. Matt has been doing a phenomenal job of getting involved with the Upstream Institute and the onboarding process for everyone. And so, yes, I certainly hope so. Everybody's great. It's just a matter of what do you pay attention to. Anything else? All right. Oh, okay.
Can you share more about, tell a little bit of background on Tim Burke?
Oh, yes. So Joe's question, can I share more background on Tim Burke? Yes, absolutely. Tim is phenomenal. He's been working at SwiftStack for about 4 or 5 years now. And he is the current most prolific contributor to Swift that we've got. All of the rest of us are in a desperate struggle to keep up with whatever's going on. And anecdotally, we get close to a release, and I'll say, "Hey Tim, what's going on?" Or somebody has a question about, I had a question about this operational thing or this bug over here, and Tim's immediate response is probably 4 patches that he's waiting on reviews on, and 3 bugs, some of which are in Python, some of which are in Swift, some of which are in whatever. And it's absolutely incredibly sharp developer. I think that as PTL, at least for the next 6 months or for however long he decides to keep that role, he's going to do great. He has an excellent grasp of not only the technology itself of what is behind Swift, but also a good idea about where we can take it. And so, as always, the key thing that we've always taken for Swift is how do we solve problems in production? How do we enable something that was not previously possible? And those sort of questions, or the answers to those questions, are what we want to be implementing. And whereas that has been my philosophy for how do we prioritize things, how do we coordinate things, how do we do stuff inside of Swift, I know for a fact that that's the same place that Tim starts from as well. What's the practical need that people have? How do we make operators' lives easier on storing petabytes and petabytes of data? How do we make applications possible to do things that weren't previously possible? And that's possible with a distributed storage system like Swift. So Tim's great. Yes, sir.
Do you have any initiative to do something else on Golang moving forward?
Do I have any intention, or is there any intention to do anything else in Golang, for example, with Hummingbird? So I obliquely mentioned that as far as some stuff that was happening in 2016 in the history of Swift. There is also some Golang code that is being proposed and developed actively right now as part of the Lots of Small Files project. The main thing, the short answer is yes, I would love to see that. It is still absolutely needed technologically, and it is a goal that we can continue marching towards. However, some of the community contraction has, and some of the other things that, there were some other things that were needed to make that work well. I mean, we can go into technical details later this week if you'd like, but there's a few things that have to get implemented before we can fully implement that in a way that allows deployers to have a rolling upgrade that just works. But as far as the idea of how do we efficiently take advantage of a whole lot of cores on a server that has a whole lot of hard drives on it and keep everything effectively busy and in full utilization is a hard problem that a lot of things in the Golang community have solved that are exceptionally difficult inside of the Python ecosystem. So yes, but not yet. It will get there. Right now I'm hoping that the Lots of Small Files work will be the first good foray into that brave new world. All right. So again, thank you very much. It's been an honor.